Alright, today we are continuing variations, and we're just going to go a little bit more in depth. Alright, so the first three boxes is going to be the formula. This one is going to be an example. Alright, and then we'll move on. So the formula for direct variation, we should know by now, y equals k times x. They're just right next to each other. Alright, and an example of that is y equals 4x, with 4 staying as the constant because we know k is constant. The inverse variation is y equals k over x. It's literally the opposite of direct variation. Remember, inverse means opposite. And an example of that, of course, is y equals 4 over x. And then finally, we have joint variation, which is y equals k times x times z. And an example of that is y equals 4 times x times z. All right. Now, an example of a direct variation graph would just be a straight line. An example of an inverse variation graph is what we just did a couple days ago, where the graph kind of looks like that with some asymptotes. And then joint variation, there's no graph. Okay? So those are the formulas. There's an example, and that's how the graphs will look. Okay? Now we have a couple examples down here. So for the direct variation, it says if y varies directly as x, and y equals 10 when x equals 14, find the constant and then write an equation to represent the relationship. So our first step is to find what k is, then rewrite the equation, how it's supposed to look. All right, so this is all we do. It gives us what y is. So we know we're looking for an equation that looks like y equals k times x because it's direct variation, right? So we have our numbers for the first one. It says y equals 10. 10 equals k. We don't know what k is. And we know x is 14. Right? So all we have to do here to solve for k is divide by 14. Divide by 14. Simplify 10 over 14 is really 5 over 7. We should know that by now. We know how to simplify. So we just figured out k equals 5 over 7. All right, so the equation we write, we don't have to solve anything else. It just wants us to write the original equation. So the original equation, so that means the equation where we don't know it's 10 and we don't know x is 14. So the original equation would be y equals k times x. And we know k is 5 over 7. So y equals 5 over 7 times x. And that would work for any numbers. It would work for 10 and 14. It would work for other numbers. That's the relationship for this equation. All right, that's it. So all we did was we took the example numbers that they gave us, we solved for k, and then we rewrote the original equation, the equation we know to start. Okay, that's it. So y equals 5 over 7x. All right, moving on. The inverse variation is said if y varies inversely as x and y equals 4 when x equals 12, find the constant and write an equation to represent the relationship. So we're doing the same thing, it's just inverse. Okay, and we know inverse, y equals k over x. All right, so let's rewrite it how we see it. We know y equals 4, so 4 equals k over 12. So we're obviously solving for k. How do we get k by itself? Multiply by 12, multiply the other side by 12. 4 times 12 is 48, so obviously k equals 48. So what is our relationship equation? Y equals 48, because 48 is our k, it's our constant, over x. And we're done. That is the correct answer. That's the equation to represent the relationship. K equals 48. Then we just plug it into the inverse equation. We got to know those equation formulas, okay? All right, moving on. If y varies jointly as x and z, then y equals 42 when x equals 9 and z equals 7. Find the constant, blah, blah, blah. Same thing. It gives us the examples. We know the joint formula is y equals k times x times z. And again, in our first example with the numbers, it gives us almost everything. We just need to find k. 42 equals k times 9 times 7. All right, so then we just work through it. 9 times 7 is 63, so k 63 equals 42. Now we divide by 63. It's going to be a fraction again, but it's not a big deal. 42 over 63, when you simplify it, again, take your time to simplify it. I just want to save us time. When you simplify it, you get 2 over 3 equals k. So we know our k is 2 over 3. Now we just fill that into the original equation. So we take what k is and fill it in right here. That's it. So y equals 2 over 3 x times z. And we're done. Simple, simple stuff. So if you ever see a question where it says, find the constant and write the equation to represent the relationship, it's easy. Just work backwards to find k and then plug it into the equation. Simple, simple stuff. All right. There's one more part, then we'll get into the word problems. There's a combined variation. Okay? Don't freak out. It's not that bad. But there's a combined variation. It says if p varies directly with q squared and inversely with r and p equals 38.4, when q equals 8 and r equals 5, find the constant and write an equation to represent the relationship. I know that's a lot. They're trying to scare you, but it's the same thing we just did up there. We just combined two of them. We're doing direct variation and inverse variation. So don't freak out, okay? So this is how it is. It says if p varies directly with q squared, all right, and inversely with r, all right? The constant, however, is right here. So k and then q squared. The way I got that was just by reading it. It says if p varies directly, so direct variation, the constant needs to be right here, with q squared, and inversely with r. So we know r is on the bottom. And p equals, so now we have our equation. We just need to fill it in. So p is 38.4 equals k, we don't know k. Q is 8 squared, which you should already know what that is, but we're going to do one at a time, over 5. Now we need to solve it. 38.4 equals k times 64 over 5. All right? So now we're going to multiply by 5 to get that going. What we do to one side, we must do to the other. All right? So now we have 38.4 times 5 is 192. And that equals k times 64, because this 5 and that 5 is gone. So I'm going to move this over here because of room. 192 equals k times 64. What's the only thing in the way of solving for k? It's the 64. So divide by 64, divide by 64. Use your calculator. K equals 3. So now we're not done yet. I'm going to now write our correct equation. Remember, it says write the equation to represent the relationship, and that is p equals, the constant we found was 3, so it just gets plugged in. So instead of writing k, write 3 q squared over r, and we're done. All right, not that bad. If you need to go back, if I went too fast, go back and watch it again, but it's not that bad. We just combined direct variation and inverse variation. A little bit of a trickier equation, but still not that bad. We solved for k, and we just plugged it in. All right, let's go through these 3 word problems, and we're good. We're done. So it says the total dollar amount D that Megan earns varies directly with the number of hours H that she works. In her last paycheck, she earned $148.5 working 18 hours. If her next paycheck is $90.75, how many hours did she work? This is easy, easy stuff. Dollars, let me change colors so I'm a little bit darker. Let's go with green. So dollars equals K, which is the constant, times hours worked. That's it. Again, the way I get that is just by reading it. The dollars she makes equals the constant times the hours, okay? So that's simple. The dollars, it already told us, is 148.5 equals, we don't know what K is yet. We're going to solve for K and then figure out the next step. 148.5 equals K times she worked 18 hours. All right, boom. How do we solve for K? That's easy. Divide by 18. Divide by 18. 148.5 divided by 18. K equals 8.25. All right, so she earns $8.25 per hour. That's basically what it's saying. That's the constant. So let's plug it back into the original equation. To what we need to solve. It says in her next paycheck, she gets $90.75. So for our next one, 90.75 equals our constant, 8.25, times H. This time we don't know what H is. So again, same thing. Divide by 8.25, divide by 8.25. H equals, again, you should have a calculator out. 90.75 divided by 8.25 is 11. And we're done. Hopefully y'all see what I'm saying. This stuff is simple stuff. All right. Moving on. Like I said, I want to try to make it 15 minutes. For Tom's savings account, the interest earned varies jointly with the principal and the amount of time in years since opening the account. If Tom opened the account 3 years ago with $1,200 and earned $144 in interest, how much interest will he have earned 8 years after opening the account? So again, we can make the equation by reading it. We know we're solving for interest. The interest earned varies jointly with the principal, so the constant is K, then the letter P for principal, and then the letter T for time. I'm not making this up, y'all. It's right there. Interest equals the constant, K is always there, and then the principal, and then the time. Jointly, interest varies jointly with the principal and amount of time in years. Now we just plug it in and solve for K. All right? So he earned, remember, interest is going to be on the outside, not the highest number. So 144 equals K, because we don't know K, times the principal. He started with 1,200. That's what principal is. 1,200, and the time was 3 years. All right, now we just do some math. 1,200 times 3 is 3,600. Okay, so we're going to divide that by 3,600, divided by 3,600. K equals, again, 144 divided by 3,600. Put it in a calculator. 0.04. So that is our K. That's our constant. So now we're going to take K and plug it in with the new numbers. So we need to figure out our interest. I equals 0.04 times 1,200, because it's the same principle. It's just asking for later, more years in advance, how much more interest will he have. So the principle is still the same. The time, though, changes to 8. So that's it. So now we multiply those three together to find out the interest. Okay? In the calculator, you put it in there, and you get I equals 384. Again, make sure you do it so you know what you're doing. And that's it. We're done. If you need to go back and see it, go ahead, okay? Finished with number 3, and then we're done. I'll be right above 15 minutes probably. Sorry, y'all. But the time it takes Adam to drive from Disney World varies inversely with his average rate of speed. That should make sense. That's every time you drive. If it takes Adam 10.8 hours at an average of 50 miles per hour, how long would it take him at an average speed of 60 miles per hour? First off, I want us to use common sense. If he's going faster the second time around, we know it's going to be less time. So if you ever do it on a test or on a question like this, and you get a higher number than 10.8, you know you did something wrong. But let's start, okay? So again, the time it takes varies inversely with the constant over his speed. That's it. Again, I'm not making it up. You get it from the problem. All right? So let's go with 10.8, that's the time it took first, equals k over 50. All right. Now we multiply by 50. Multiply by 50. This is to get what k is. 540 equals k. So we found our constant. Now we're going to take the constant and plug it in with the new speed. So the time it takes t equals 540 divided by 60. Because he's now going 60 miles an hour. That's where I get the 60 from. We used 50 earlier, but now he went 60 miles an hour. So 50 is done, 10.8 is done. We found k, so we plug it in. So the time it takes him this time is 540, the constant, divided by 60. 540 divided by 60. You shouldn't need a calculator, but if you do, that's fine. The time it takes is 9 hours. And we're done. All right? Because 54 divided by 6 is 9. That's why I said you wouldn't need a calculator. All right? Pretty simple stuff. It only took a while because I had a lot to cover. We had the formula. We had an example. I showed you what the graph looked like. I did 3 examples. Then I told you about combined variation on the first paper. Then on the back, we did 3 word problems. That's the only reason it took long. Okay? This is simple stuff. Finish the assignment. Turn it in. Should be good.